Good morning, everyone. So I'm going to talk about digital engineering and the revolution in product development, with a particular focus around automotive. That's my background, but you'll see hopefully through these slides that there's an increasing relevance and commonality across multiple sectors. So we'll talk a little bit about the background and the current status of product development, and what the future state might look like. Bring that to life a little bit with some example cases, and then try and draw that together into some conclusions. So, engineers have helped to shape the way we live today quite extensively. If you look at some of the examples, just two actually given here, and the point on the right-hand side is that that influence, I think, will increase significantly. Neville mentioned looking forward is a bit like science fiction at the moment, and it's almost whatever you can imagine could come into being in the future. Very, very complex products, or the potential for complexity, and who knows where we could get to, very much influencing the way we live and interact. And undoubtedly, when you look at the example cases here, it's very cross-sector. And as we dig into this and the tools and techniques and the skills required, we start to see that a lot of that is common across multiple sectors and applications. That's a key point. So what is the challenge? Very much around the underlying complexity increase within our products. It's a bit of a virtuous circle, really, because as you have more capability in your tools, techniques, and skills, and some of the capabilities that Neville was indicating, so we can create more complexity. And I think, coming back to one of the questions and Neville's response, I wholeheartedly agree that there won't be a reduction in the requirement for engineers. Quite opposite, it'll be an increase, because the expectation will keep moving in this exponential form. And I think that the point to note is that our skill sets will have to be different to what they've been in the past, and perhaps we'll have to be a bit more broad than we have been as well. So what we're saying here is that there will be this product complexity. It will be pulled by the market, but we want everything else as well. That will be a sort of qualification requirements for industry. So yes, it's groundbreaking products, but it has to be right every time. We want perfect quality, right first time and every time. We want to be faster to market because the competition is driving that and the market demand is there, and we want to spend less money in doing it. So how do you create all of that in one hit? Well, there's a number of key factors here. One is collaboration, and I think that's going to be a really key word for us over the next 10, 15 years, between companies in the same sector and then cross-sector as well. And in many cases, the latter is often easier because there's no competition. You're not fighting for the market share in your own sector. Virtual tools and techniques, absolutely critical. So we'll talk a little bit in a minute about virtual verification and certification. It's a very expensive and very long drawn out process, certainly in automotive and definitely in aerospace and defense as well. How do you dramatically decrease the time required to get these products to market? And then the underlying tools and techniques very much on a digital platform that we'll be using to get into that space. Great opportunity here, big set of challenges, but with those challenges, always there's opportunity. And I think the UK, building on Neville's presentation, has a fantastic opportunity in this space. But we've got to get on the front foot and get out of the blocks before the others, and get moving. So, quick look at the current process for developing a product. So, this is the classic V diagram. I'm sure we're all familiar with it, where you drive down the left-hand side, you've got a concept level, so you're architecting a product, and then you're getting into system level, component level, driving into the supply chain, and then you put it all back together again build up your product through component verification, system level verification, and then the whole product, and then you certify and get it to market. Historically, it's been a very empirically based process, demanding a lot of physical hardware. So in the auto industry, that's a lot of prototype cars, and they're often very expensive. They also take a long time to build and develop, and in many cases, particularly at the early stages of a project, at the sort of concepting front end, they're not that representative of the end product. They're a cut and shut version of what you have today, trying to project itself forward. And I guess when you look forward to autonomous as well, that becomes the burning platform for automotive, because you simply cannot drive enough miles to verify and certify the product. So you have to do that virtually, and we're challenging ourselves to work out how that's best done. It's a complex area, and we have to work very closely with the regulators to understand that, and that is very much a cross-sector challenge. So in the future, and this is perhaps a different way of viewing what Neville has presented already, we're looking to squeeze that V. How do you take time out of this process by making each step easier and faster? Investing in the left-hand side of the diagram to give you benefit, not only in the left-hand side of the diagram, but also in the right-hand side. So if you've got, for example, models that are fully validated at those different levels of architecture in the product, can you use those to support your verification and your certification process on the right-hand side? And I think the answer is yes, but we need to put more effort in to get those models in the right shape. And this is a really simple example. I guess I apologize for the simplicity of it, but it kind of helps to understand the enormity of the change that we're going to have to go through. So I use the example here of considering 4 e-motor architectures in a new vehicle product. Today's process would typically be to take 4 e-motors, build 4 prototype cars, probably £0.5 to £1 million per prototype, and taking in total the program perhaps 12 months to evaluate each of those options, interacting with the supplier. It's expensive, it's slow, and if you choose one in the end, 3 will be wasted. So project to the future, what we need is 4 certified, and that's a really important word, certified e-motor models. So that's not a bit of marketing information that's uncontrolled. That has to be certified to a standard by an industry recognized source. You take those models, black box form, plug it into the vehicle architecture, and make your assessments of those e-motors. If they weren't performing as you wanted them to, or you wanted to develop them further, you'd be going back to the supplier to ask them to enhance the attributes, the capabilities of their product. They would hold the detail. They would have all the test data and the validation data. They'd have the detail of the designs. They would work that space and come back with an updated model. And you do that across the patch in all 4 cases. So at that early stage of the program, you've not built any hardware at all at the OEM level, at the vehicle level. You may well have some hardware on rigs of the supplier for the validation process, but you've expedited the whole activity. So just looking at that process, as OEMs, we're moving in this direction. The supply chain probably hasn't really got this on its radar, not firmly on its radar at the moment. To be competing for the business with OEMs in the future, you need to be able to talk this language, and the language will be in the form of digital, in models that are validated and certified to an agreed standard. So you start to think of it on that scale, and you can understand the size of the transformation that we need to be going through. So a few examples here to bring this to life. I'm going to refer back to many years ago now when I was involved in Formula 1 We had a race team and a test team that ran in parallel. So at any point in the year, we were typically active somewhere on a circuit, somewhere in the world. The testing was gradually reduced until in the end it was largely deleted. We still have a couple of weeks of testing pre-season, but otherwise we are not testing the car. And that was to make it easier to control costs. It's obviously very expensive deploying that many people to various locations around the world and running all this hardware. So with that deletion came the need to do something else. It's still a competitive environment, very competitive environment in Formula One. We had a vehicle simulator and we used it to an extent, but not anywhere near as much as we do today. So we turned our attentions to the simulator, really put a lot of development effort into it, and to the point where today over 95% of the car setup, so before the race weekend, is done virtually. So you look at that capability and you say, okay, so is that interesting into mainstream automotive, and can we support the paradigm shift with some of these tools and techniques? So another example here is P1. This is going back some years now, but it's one of my favourite cars from the range. It was the first hybrid supercar, very complex platform, very challenging, but it was concepted and delivered within 24 months. So that, in comparison to the indicated timeline from Neville, typically maybe 5 years for an automotive product, this really did challenge the paradigms. We did that, I guess, not overly consciously at the time. We kind of wandered out of racing into automotive with our tools and techniques that we typically used in Formula One racing. I guess we didn't know what we didn't know, and probably if we had have done, we might have run a mile from automotive because we'd have not had enough budget and not really known what to be doing. So we started concepting our products virtually from the off. So very few prototype hardware units in the early stages. More so later in the program for validation. We're probably not as strong there as we need to be. But in this case, it was a fully virtual concept for the car. And we signed the car off to go to production in the virtual form. So really significant step. And what we found is that in doing this and launching the cars that we've launched, sector leaders, then the rest of the industry has turned around and said that's actually really interesting, because we need to do more of that ourselves with all the challenges that we're facing. We need to understand how you've delivered that level of technology in that time frame. So the real question is, the tools and techniques that we used, do they actually scale? So from Formula One racing car to P1 road car to Ford Transit. Perhaps not the obvious link that you'd make, but actually the Ford Transit is a really complex product. I think in theory you can order over 1 billion different variants of the Transit. And there's a number of systems on that car that are safety critical and need to be validated in detail. And that program alone, that safety critical system validation, would typically take about 18 months for the variants that of the product that have to be delivered worldwide. And that'll get worse because, no surprise, there'll be a level of electrification in the Transit, so the complexity is rising in line with our expectations. And so we've got a product here that has some time determining steps in its design and development and verification phases. And so what we've done here is create a statement project. So can we take this challenge on for the next generation of the Transit and take some of those tools and techniques that I've touched on and use them in this environment? And when we do, how applicable are they and what benefits do we get? And I guess one example case at the moment, so one of those safety critical systems might normally take in total the larger part of an 18-month program to go through all the variants. We're now down to 3 days, and we believe it could be less than 24 hours if the models are set up well and you've got the computing power behind it. So some really, really significant shifts. These aren't sort of bite-sized chunks, these are massive leaps in what can be achieved. And so this is very much the statement project from the APC and automotive industry as to what this digital transformation is all about and what benefits we can deliver. And so we're pushing this one forward as a lead into Brunel that Neville mentioned earlier. So in conclusion then, we are facing an unprecedented level of change and challenge. I think it's widely accepted now that the auto industry is going to change more in the next 10 years than it has done in the last 100 years. But then, of course, with challenge comes opportunity. And as we've touched on, the UK, with some of our technology and capability and skills, is extremely well placed to exploit those opportunities. But we must collectively embrace that. It must be cross-sector. We must collaborate as well. Again, I think that's a really key word for the next 10, 15 years. And we shouldn't be frightened of challenging the paradigms. So that's a conclusion of my presentation.